All right, you bastards. Strap yourselves in for one wild-ass ride. We're diving deep into the goddamn universe today.
It's all about perspective.
Yeah, from the tiniest shit imaginable
Building blocks of reality.
to those giant balls of fire we call stars. You think you got a grip on scale?
To the cosmic.
Think again. We're about to blow your fucking mind.
Where galaxies waltz across the universe.
Let's cut the crap and get right to it. We're starting with the smallest shit imaginable, something called the Planck length. What the hell is this thing anyway?
The Planck length is like the universe's pixel.
Like a pixel.
About 1.6 by 10, 35 meters.
Jesus.
That's a decimal point followed by 34 zeros, then a 16.
So it's small.
It's so small, if you tried to measure anything smaller, the laws of physics as we know them, well, they go out the window.
Holy shit, that's smaller than my dick after a cold shower. Seriously though, are we talking smaller than quarks?
Quarks and electrons are what we call point-like particles.
Point-like.
Meaning they don't have a size in the traditional sense. It's like trying to measure the width of a point on a piece of paper. It doesn't really have one.
So basically it's all a bunch of theoretical bullshit at that level.
Not bullshit, just beyond our current ability to directly observe.
Okay.
But based on how those particles interact, we know they're unbelievably small.
All right, fair enough. My brain's already starting to hurt, so let's move on to something a bit easier to wrap our heads around.
Yeah.
What's next on this cosmic measuring stick?
We'll jump up a few levels to protons and neutrons,
Okay.
hanging out around 10-15 meters, also known as a femtometer.
Huh.
Then you've got atoms, like a hydrogen atom, chilling at about 10 meters.
Still tiny.
Or 100 picometers. That's where we start seeing wavelengths of powerful stuff like gamma rays and X-rays.
So we're still in the microscopic realm, but at least this is stuff we can actually use to, like, zap cancer.
Exactly. And those sizes, tiny as they are, they're still gigantic compared to that Planck length. It's all relative, you know.
Okay, I'm starting to grasp this cosmic ruler thing. So when do things get big enough for us to actually see them without needing a fancy-ass microscope?
Around 10 to 6 meters, 1 micrometer.
Okay.
We find bacteria, the bad boys of the microscopic world. You'll also find things like fog droplets and, surprisingly, the width of a human hair.
Hold up. A human hair? Shit, that's way bigger than I thought. So we're finally out of that need a microscope zone.
Just barely.
Okay.
At 10-3 meters or 1 millimeter, we encounter things like mosquitoes and, believe it or not, bullets. Still small, but you can definitely see them.
Especially if one's coming right at you. All right, we're at the millimeter mark now. What comes after that? Let's get to some real-world shit.
Moving on up, we hit centimeters. Think about your credit card.
Sure.
About 8.6 centimeters long. And while we're on the topic of everyday objects, a baseball comes in at around 7.5 centimeters in diameter.
Okay, now we're talking. What about a meter? Are we in the realm of human-sized objects now?
You got it. A meter is roughly the height of a doorknob. Think about things like pianos, cars, hell, even a goddamn sperm whale. All in the meter range.
All right, that paints a picture.
Yeah.
But let's keep this cosmic elevator moving. What's next?
We're entering the decameter range, which is 10 meters. Think about a double-decker bus. Those behemoths are about 8 meters long.
Right.
And for a truly impressive sight picture, the Statue of Liberty standing tall at 93 meters.
Damn, Lady Liberty's a big bitch. Okay, let's climb this ladder even higher. What's bigger than a decameter?
Next up is the hectometer. That's 100 meters.
Yeah.
Imagine a football field stretched out, or the Eiffel Tower piercing the sky. Both fall into this scale. And let's not forget Niagara Falls, that majestic beast cascading down from about 52 meters.
Okay, now we're talking serious size.
Mm.
But we're still stuck on this rock we call Earth. When do we finally blast off into space?
Hold your horses. Things are about to get a hell of a lot bigger. Buckle up as we transition to the megameter 1 million meters, or 1,000 kilometers.
1,000 kilometers.
Now we're talking planetary scales.
Finally, we're leaving this goddamn planet. Hit me with some cosmic comparisons.
All right, picture this. The diameter of our pale blue dot is about 12,742 kilometers. But our neighbor, Mars, is a bit smaller, clocking in at just 6,792 kilometers in diameter.
Yep.
And then there's the moon, even smaller, at about 3,476 kilometers.
So even in this megameter range, there are some massive differences in size. What about those gas giants, the big boys of our solar system?
Let's talk about Jupiter, the king of planets. Its diameter is a whopping 142,984 kilometers.
Whoa.
That's more than 11 times the diameter of Earth.
Wait, you're telling me you could fit 11 Earths side by side across Jupiter? That's fucking insane.
It is pretty mind-boggling. And remember, we're still just talking about our little corner of the universe, a tiny speck in the grand scheme of things.
So what's next on this cosmic size chart? Are we going galactic yet?
Not quite. We got to talk about the big cheese of our solar system, the sun. Now, this is where things get truly wild.
All right, lay it on me. How big are we talking?
The sun's diameter is a colossal 1,392,700 kilometers.
Jesus Christ.
That means you could fit over 100 Earths across its face.
100 Earths?
And over 1,000 Earths could fit inside it.
Holy shit. Now that's what I call a big-ass motherfucker. I'm starting to feel pretty insignificant here.
Well, that's kind of the point of this whole journey, to appreciate the vastness of the universe and our place in it.
Okay, but let's not dwell on my existential crisis just yet. We've got more universe to explore. What comes after the sun? Do we finally get to those light years I've heard so much about?
You got it. To measure the truly mind-boggling distances between stars and galaxies, we need a bigger ruler, the light year. All right, folks, let's get back to this mind-blowing cosmic road trip. Last time we were trying to wrap our heads around the light year, which, if you remember, is the distance light travels in a year, and let me tell you, that's one hell of a distance.
Yeah, my brain's still a bit fried from trying to comprehend 1,000 trillion kilometers.
Yeah.
So a light year is how we measure those crazy distances between stars and galaxies. But what the hell's a light year in actual, normal people terms?
Okay, imagine this. You've got a spaceship that can somehow travel at the speed of light, the fastest thing in the universe, clocking in at almost 300,000 kilometers per second. You hop in, hit the gas, and a year later, you slam on the brakes.
A year later?
The distance you've traveled, that's a light year.
Damn, so even at that ridiculous speed, it takes a whole year to travel 1 light year. Space is fucking huge.
Yeah.
So tell me, how far away are some of those twinkling stars we see every night?
Well, the closest star to our sun is Proxima Centauri, a little over 4 light years away. That means the light we see from it tonight actually left the star over 4 years ago.
So basically, we're looking back in time when we look at stars. That's some trippy shit.
It is, and it gets even crazier.
Yeah.
Serious. The brightest star in our sky is about 8.6 light years away. And if you look at the constellation Orion, the star Betelgeuse is a whopping 642 light years away.
600 and...
That means the light we see from Betelgeuse started its journey towards us way back when the Black Death was ravaging Europe.
Shit talk about ancient history. But those are just individual stars, right?
Yeah.
We haven't even gotten to galaxies, those massive collections of stars. What's the deal with our own galaxy, the Milky Way?
The Milky Way is a barred spiral galaxy.
Barred spiral.
Imagine a flat disk with spiral arms and a bar-shaped center. It's estimated to be about 100,000 light years across.
Hold up. 100,000 light years. Even traveling at the speed of light, it would take 100,000 years to cross our own damn galaxy. That's just insane.
It gives you a sense of just how vast things are, right? But it gets even wilder. The Andromeda Galaxy, our closest major galactic neighbor, is a staggering 2.5 million light years away.
2 point.
The light we see from Andromeda today began its journey millions of years before humans even walked the Earth.
Damn, that makes you feel pretty insignificant. So we've got these giant galaxies spread out across the universe. Are they all spiral-shaped like the Milky Way?
Nope. Galaxies come in all shapes and sizes. Spirals like ours, and Andromeda elliptical galaxies, which are more rounded, and irregular galaxies, which are, well, kind of all over the place. It's a cosmic zoo out there.
So what determines their shapes? Is it some kind of galactic beauty contest?
It's a wild mix of gravity, the galaxy's rotation, and the amount of gas and dust it contains. And here's the kicker. Galaxies aren't just sitting still. They're constantly moving and even smashing into each other.
Wait, galaxies collide, like some kind of intergalactic demolition derby. That's fucking metal.
It's more like a slow-motion dance that takes millions, even billions of years. But these collisions are epic events, distorting galaxies, triggering star formation, and reshaping the universe.
So it's chaos out there with these galaxies smashing and merging. What's even bigger than a galaxy? Is there a cosmic king of the hill?
Well, galaxies themselves hang out in groups like cosmic neighborhoods. Our Milky Way, for example, is part of a group of about 54 galaxies called the Local Group, which also includes Andromeda.
So it's like cosmic cliques. But wait, are there even bigger groups? Like galactic gangs?
You got it. These galaxy groups then gather into even bigger structures called superclusters. Our Local Group, for example, is part of the Virgo supercluster. It's like a whole hierarchy of cosmic organization, from individual galaxies to clusters to superclusters. It's mind-boggling to imagine.
Okay, so we've got these superclusters of galaxies spread across the universe. What's the biggest thing we've found out there so far? Anything that truly takes the cake.
The biggest thing we found so far is something called the Hercules Corona Borealis Great Wall. It's this ridiculously massive structure, a colossal cluster of galaxies that stretches for an estimated 10 billion light years. That's like the Great Wall of China on a cosmic scale.
Holy shit, that's mind-blowing. How in the hell do we even know something that big exists?
It's all thanks to these insanely powerful explosions called gamma ray bursts that happen when massive stars die. They're like cosmic beacons allowing astronomers to map out the universe. By studying the patterns of these bursts, they stumbled upon this gargantuan structure.
So we're using exploding stars to map the universe. That's some next-level shit right there. But hold on, if this Hercules Corona Borealis thing is the biggest in the observable universe, does that mean there's even bigger shit out there we just can't see?
That's the million-dollar question, and one that keeps astronomers up at night. The observable universe is just the part we can see from Earth, limited by how far light has had time to travel since the Big Bang. The universe could be infinitely large, or just way bigger than what we can currently see. Who knows what crazy structures might be lurking out there beyond our cosmic horizon.
Damn, that's some freaky shit to think about. This whole conversation's making me feel like I need another drink.
Let's take a quick break and come back to explore those mind-bending possibilities in part 3. Welcome back to the Deep Dive Space Cadets. We've been exploring this mind-blowing cosmic playground from the subatomic to the supergalactic. Last we left off, we were pondering the possibility of structures even bigger than that Hercules Corona Borealis Great Wall hiding out in the vast, unobservable universe.
Yeah, that shit really baked my noodle. It's hard enough wrapping my head around the stuff we can see, let alone what's lurking beyond our cosmic horizon. So let's get back to that question. What if the universe is infinite?
Right.
Does that mean there are infinite copies of me out there living different versions of my life?
Mhm.
Like, is there a me out there right now banging a supermodel while sipping champagne on a yacht?
That, my friend, is where we enter the realm of the multiverse.
The multiverse.
A theoretical concept that suggests our universe might just be one of many, perhaps an infinite number. Imagine it like a loaf of bread with each slice representing a different universe, each with its own set of physical laws and constants.
So you're saying there could be a universe where I'm a goddamn rock star instead of this podcasting gig. Sign me the fuck up. But seriously, is this multiverse thing just some stoner thought experiment, or is there actual science behind it?
It's definitely mind-bending, but the idea arises from some pretty solid physics, like cosmology and quantum mechanics. We don't have direct evidence for it, but it's a compelling theory that attempts to explain some of the weirdness we see at the quantum level.
All right, let's say for a minute that the multiverse is real. Does that mean we can hop between these different universes? Can I grab a beer with my rock star self and get some backstage passes?
Unfortunately, that's where current physics hits a wall. As far as we know, there's no way to travel between universes. It would require us to figure out how to manipulate the very fabric of space-time, something far beyond our current capabilities.
Wow, that's a real buzzkill. So we're stuck in this universe even if there are countless others out there. What a cosmic bummer.
It seems that way for now. But who knows what the future holds? Science is constantly evolving, and maybe someday we'll crack the code of the multiverse. Until then, we've got plenty to explore in our own little corner of existence.
Well, that's true. We've traveled from the smallest imaginable scales to those mind-boggling cosmic structures. It's all pretty damn humbling, to be honest. Makes you realize how small we are in the grand scheme of things.
Absolutely, but it's also pretty damn amazing, isn't it? We're these tiny, insignificant creatures on this pale blue dot, yet we have the capacity to comprehend the vastness of the universe and our place within it. That's pretty special.
Yeah, I guess you're right. Knowing all this stuff doesn't really change my day-to-day life, but it's definitely given me a new perspective on things.
That's the beauty of it. The more we learn about the universe, the more we realize how much more there is to discover. It sparks curiosity, wonder, and a sense of awe, and that's something worth cherishing.
All right, you magnificent bastards. That's a wrap for this deep dive. We've journeyed from the subatomic to the supergalactic, and hopefully we've blown your minds along the way. Go out there, look up at the night sky, and contemplate the sheer scale of it all. And maybe have a drink while you're at it. Later, dudes.
Until next time.